The story goes that Sir Isaac Newton was looking at an apple falling from a tree when he discovered there must be some magical force that is pulling it downward. He dubbed that force gravity. Today we will learn how to write a few lines of code and produce our own gravity effect and make a ball bounce in Unity. Simulating gravity is surprisingly simple, as you can see with these 4 lines of code. The star of the show is right here on the first line, where we're setting the current acceleration to the gravity, which we've set to -9.8 in Unity, and we'll be multiplying that to time.delta time, which in fixed update is usually 0.02 seconds, and we'll multiply that again by 0.02 seconds, and we'll be adding the previous acceleration to that. Now, previous acceleration will start off as 0, and then with each iteration we save current acceleration into previous acceleration to be used for the next iteration. Next, we set the acceleration vector to the x to ball.transfer.position.x, since we are just having the ball drop straight down in the y direction. So we are just setting the y coordinate to the current acceleration. Z will be 0 because we are working in 2D. Finally, we'll add that acceleration vector to the ball transform.position vector. Let's see this in action. That is pretty cool, but we do want to make this ball bounce. To do that, we need to add this if statement. Let's get into it. Essentially, we have this player screen, right? And we have this ball that's dropping, it's dropping. At some point, it might be surpassing this bottom edge of the window. And when it does, we want to move it back up right to the edge of the window. To do that, we'll find the center of the ball, which is given by ball.transfer.position.y. We'll subtract the radius from it, and we'll check if that scalar is less than or equal to the bottom of this window. And we get that by using camera.main.screen.worldPoint, and we're just checking the bottom of the screen over there. So if it did surpass, like it did over here, what we'll do is we'll set the ball transform.position to the bottom edge of the window minus the ball radius. So essentially what we're doing here is we're just moving it back up to hitting the bottom edge, hitting the bottom of the window. Now what we have to do is send that ball bouncing back up, right? So to do that, we'll take the previous acceleration, which is equal to the current acceleration in this fixed update iteration, and we'll set it to previous acceleration times -1. Why -1? Because we're flipping the direction, and then we also will lose some energy. If you bounce a ball, it doesn't bounce at the same rate, right? It starts bouncing less and less and less until it comes to a standstill. So that's what this bounce factor is for. And currently we've set this to 0.8. So it's losing about 20% of energy every single time. Let's try that out. Success. Let's get a little deeper into this line over here, this equation. How was this derived? So gravity is equal to 9.8 meters per second squared. That is the same as saying 9.8 meters per second per second. What does that mean? If you have a ball over here at 0 seconds, you drop it for 1 second, the speed at the beginning will be 0 meters per second. After 1 second, it would have accelerated to 9.8 meters per second. Okay, so 9.8 meters per second is the acceleration. So if we drop it for another second, so the total time is 2 seconds, over here we'll have 9.8 meters per second plus 9.8 meters per second, which will give us a total of 19.6 meters per second. So you can kind of see how we've built this line, right? We keep adding the previous acceleration to the current acceleration. Okay. Also, there might be some confusion. If you look at this equation over here, you're seeing gravity is multiplied by the delta time multiplied by the delta time. But if we look at the original gravity equation, it's divided by the time squared. So what's important to know is that time.delta time is a fraction, right? So we really want to put that in terms of 1 second. So G is equal to 9.8 meters per second squared, but here we have to put time.delta time as a fraction of a second, right? So that's equal to 1 divided by 0.02 times 1 divided by 0.02. And if you remember your division rules, you can flip this over. If you multiply, so that will be 9.8 times 0.02 over 1 times 0.02 over 1. And these canceled out, so basically you get this equation over here. Time for a code review. Please don't be too harsh on me. Okay, let's start. We're going to be using the TextMesh Pro for labels. That's why you see that over there. And then we set a bunch of class variables. Serialize field is used for showing your variables in the Unity editor, so you can control it there for easier access. And also allows you to add a private access modifier to keep encapsulation in check. So we have the ball mass, we're going to control that. We're not actually using that in this scenario just yet because we're not having different size balls or different mass balls bouncing against each other. But I have that maybe for future usage. Then we are setting the gravity. And this over here, the ball sprite pixels to 1 unit, is just to control the size of the sprite. There's probably a better way to do that. And also the bounce factor, which we said is set to 0.8. And then the draw unit grid is just a boolean. We can turn it on or off. That will set the unit. Each unit in Unity is basically equal to 1 meter. So I'm just drawing, 5 meters, 4 meters, 3 meters, 2 meters, 0 meters, and so forth on the grid, so that I can go and see if my calculations are actually correct, by dropping a ball and then checking the distance that it dropped after 1 second, 2 seconds, and so forth. We also want to set the font size. Next, we have the previous acceleration, the ball radius, the start time. Canvas object that is used for the TextMesh Pro to show labels. Acceleration per second calculated. This was used for some logging. And then I'm going to set some vectors for the corners of the screen. That's going to help me with figuring out how to draw the grid. In Start, we're setting up the Canvas object. Again, that is for TextMesh Pro, so we can draw labels. In here, we see we're calculating all the corners, the left bottom, the right bottom, the left top, the right top, and I'll use that again for grid drawing. And next, we have this if statement. So if draw unit grid is clicked in the editor window, we'll go ahead and draw the grid. Then we'll create the ball game object. I like staying organized, so I'm just setting that ball to this transform of this object we're in. And then we'll add the sprite renderer so that we can essentially add a texture, give it a name for the actual ball. That will be that circle. It represents the ball, and we'll also change the color to white. And over here we're creating the sprite and give it some dimensions. And we're getting the ball radius and so forth for logging. Now we get to the fix update. At the beginning we have some variables set again for logging. And you remember this code over here. I've added some comments just to make sure all my calculations are correct. And one thing over here that's of interest is that the distance traveled is equal to half g times t, right? So if the ball has traveled for 1 second and the gravity scalar we've set to 9.8, then after 1 second we should measure around 4.9 meters. You would think maybe, oh, after 1 second it should be 9.8 meters, but again, this is an acceleration. At 0 seconds, it's not moving. 0.1 is moving a tiny bit more. So if you wanted to see how far it traveled cumulatively, you have to use this equation, which is a half gravity scalar times the time, right? So again, after 1 second, it should be 4.9 meters. And if you were to download this code in GitHub, which I provide the link below, you can actually play with it and pause it, and you'll see after 1 second it's around 4.9 meters. Okay, so that was kind of just fact checking that my code's working correct. Here I set the acceleration vector. We looked at that before. You've seen all this before. Here I'm just calculating acceleration per second for logging. And we know about this if statement, and at the bottom we are just logging a bunch of stuff. I like to see that. Again, I was just kind of checking what's happening, making sure everything's good. We are not using update, we're using fix update. Update is used more if you're doing something, you know, UI wise, GUI in the GUI, but we're just doing something in physics, so you want to add it in fixed update so that you have equally spaced updates, so it looks more accurate. Okay, over here we're adding the draw unit grid function. You can go ahead and look at the code, but essentially we're using those variables. We set up the different corners and line render just to draw lines from left to right across the screen for every single unit in Unity. Again, in Unity in general, 1 unit is equal to 1 meter. Okay, and then lastly over here we have this place text function, which we use to just place the different fonts or the different labels at different positions, and we'll send in the text, for instance, 5 meters, 4 meters, 3 meters, and so forth. And that is it. Let's take a look at Unity and the different values I gave to the variables coming through in the editor. Ball mass, we're not really using it right now. Gravity, negative 9.8. The ball sprite pixels, that controls the size of the sprite. The bounce factor is essentially how much energy the ball is losing on every single bounce. Let's look at that. Right now it's set to 0.8, losing 20% per bounce. If we were to change this to 0.99, it won't lose too much energy on every single bounce. So you'll see it bounces pretty high. It takes a while for it to slow down. If we set it to 0.1, it's gonna lose 90% of energy on every single bounce. So, oops, it slowed down really quickly. Maybe that wasn't a good one. Let's try 0.5. Let's see what happens there. There you see the effect, so that's pretty cool. Let's put it back to 0.8 8. And one thing I wanted to do is look at the ball distance after 1 second to make sure it's around 4.9. That was the equation we did, right? Gravity is equal to, or distance, ball travel is equal to half gravity times time. So we play. Let's go look at the logs. And after 1 second, the distance traveled is 4.9 meters. So that is correct.